What if I told you the largest things in the universe aren't stars, planets, or even black holes? And the biggest object we've discovered might not be supposed to exist at all. Think Earth is big. Shrink it down to the size of a small globe. Suddenly, Jupiter becomes a giant sphere towering beside it. But here's the strange part. Compared to the Sun, Jupiter almost disappears. If Earth were just 12 centimeters wide, the Sun would be the size of a school bus. And that's only the beginning. Today, we're climbing a cosmic ladder where every step makes the last one look microscopic. First stop, Jupiter. A planet so enormous that more than 1,300 Earths could fit inside it. But Jupiter isn't just big. It may be one of the reasons you're alive right now. Its gravity acts like a giant shield, deflecting dangerous asteroids and comets that could otherwise slam into Earth. But that's not even the craziest part. Scientists discovered a planet called ROXs 42b, and it completely blurs the line between planet and star. At first glance, it looks like a giant gas planet. But look closer. Something doesn't add up. Normal planets form slowly from leftover material around newborn stars. ROXs 42b may have skipped that process entirely. Instead, it appears to have formed the way stars do. So why isn't it a star? Because it failed. It never gathered enough material to ignite nuclear fusion. Imagine a star that almost existed. A cosmic object trapped between two identities. A failed star wearing the disguise of a planet. And this is where it gets weird. Deep inside, scientists believe its core may still glow with leftover heat from its violent birth. A planet with the heart of a star. But even this giant is insignificant compared to what comes next. Because planets have limits. Stars don't. And when stars begin dying, they transform into something so large it becomes difficult to comprehend. What happens next changes everything. Because our Sun, the giant that dominates our solar system, is actually considered average. And once you see what's out there beyond it, average starts looking very, very small. The Sun contains almost all the mass in our solar system. Everything else, every planet, moon, asteroid, and comet, is basically cosmic leftovers. But here's the strange part. The Sun is nowhere near the largest star in the universe. Take Sirius A, the brightest star in our night sky. Most people assume it shines so brightly because it's enormous. Wrong. It's bright because it's close. And that illusion hides something important. As stars age, they begin changing in ways that seem impossible. They swell, expand, and become monsters. One example is Pollux, a red giant star that reveals our own Sun's future. Billions of years from now, the Sun will expand dramatically. Mercury will vanish. Venus will disappear. Earth might be swallowed too. But that's still not the craziest part. Because beyond red giants lie supergiants. And among them is a legendary star called Betelgeuse. A star so huge that if placed where our Sun is today, its surface could stretch beyond Mars. Maybe even farther. And right now, Betelgeuse is dying. Astronomers know it's living on borrowed time. Tomorrow? 10,000 years from now? Nobody knows. But one day it will explode. When it does, it could shine brightly enough to be visible during daylight. A star turning into a second sun in our sky. Sounds unbelievable. Yet it gets even bigger. Enter Stephenson 2-18. One of the largest known stars ever discovered. If it replaced our Sun, it wouldn't stop at Jupiter. It would engulf Saturn. Imagine flying around its circumference in a passenger jet. You wouldn't finish the trip in a day, or a year, or a century. It would take roughly 1,500 years. Let that sink in. A single lap. One star. But then comes the twist nobody expects. Despite its unimaginable size, Stephenson 2-18 is not even close to the largest object we'll encounter. Not even remotely close. Because the universe has something far more terrifying waiting in the darkness. Something that bends space itself. Something whose size is measured not by fire, but by gravity. And that's when black holes enter the story. Black holes are usually described as dense, massive, deadly, but some are also unbelievably large. Take TON 618, a black hole so enormous that it makes giant stars look tiny. Its gravitational boundary stretches across distances that dwarf our entire solar system. And this is where it gets weird. Scientists estimate it contains tens of billions of times the mass of our Sun. Yet even TON 618 isn't the biggest black hole known. That title may belong to Phoenix A, a monster so large that researchers struggle to explain how it formed. According to current models, there simply hasn't been enough time since the Big Bang for something this huge to grow, which raises an uncomfortable question. Did we misunderstand how black holes evolve? Or are we missing part of the story? But then the universe pulls one final trick. Because black holes aren't the largest structures we've discovered. Galaxies are bigger, much bigger. Our Milky Way contains hundreds of billions of stars and stretches across 100,000 light-years. Sounds enormous. Until you compare it to Andromeda. Then compare both to IC 1101. Then compare those to vast cosmic structures spanning billions of light-years. And that's where we find Kipu, a gigantic network of galaxy clusters stretching across space like a glowing cosmic nervous system. Impossible to imagine, yet still not the biggest. Because beyond Kipu lies something so absurd that even its discoverers doubted it was real. The Hercules-Corona Borealis Great Wall, a structure stretching roughly 10 billion light-years, nearly a tenth of the observable universe. Think about that. A single structure occupying a significant fraction of everything we can see. According to our understanding of cosmology, something this large should not exist. It shouldn't have had enough time to form. And yet, there it is. Silent. Waiting. Forcing scientists to question the very rules that describe reality itself. So after traveling from planets to stars, from black holes to galaxies, we arrive at a disturbing conclusion. The biggest thing we've found may be something the universe never should have allowed. Which leaves one final question. If something this impossible already exists, what else is hiding beyond the edge of what we can see?